Alright, a car moves with a constant speed of 18 meters per second for a time of 6 seconds and then does not move for 4 seconds. So if I'm looking at times here, I've got 6 seconds and 4 seconds, giving me a total of 10. So on both my axes here, I'm going to start at 0 and go up to 10. And on my x-axis, on both sides, I have a time in seconds. Alright, on my first graph here on the right, I'm going to make this be velocity in meters per second. And I know that it needs to go up to 18 meters a second. And then after that, it doesn't move, so I'm not going any higher than 18. So if I count up 3, 6, 9. Oh, I'm going to run out of room there. We'll go up by 4s. So 4, 8. All right. Now, if I travel 18 meters a second for 6 seconds from 0 until 6, I should have a flat line at 18 meters per second. And after that, I don't move. So from 6 to 10, I have a flat line here. I'm going to connect those with a dotted line. Now, in order to figure out the position, I need to know the area of this segment that I am highlighting in yellow here. So if I take the area of this segment, I will be able to figure out the total distance that I travel. So the total distance that I travel, I have a height of 18 times a width of 6, gives me a total distance of 108 meters. So if I'm going to label this graph, that is segment A. Segment B here, there's nothing underneath it, giving me 0 meters. So I always like to add up my total distance. 108 meters and 0 meters gives me 108 meters total. All right, now I am going to go up on my position side, and this is in meters by 30s. So 30, 60, 90, 120, 150. So my position starts at 0, 0. After 6 seconds, I've traveled my 108 meters. So 6 seconds at 108. You should use a ruler to get a nice straight line. For the last 4 seconds, I don't move, giving me a flat line at 108.